Okay, an equilateral triangle is also equiangular. All the sides are equal in length and all the angles are equal in measure. An equilateral triangle has 60-degree angles at each of the vertices. So let's take an equilateral triangle that has the length of the sides 2. Could be 2 meters, 2 feet, 2 centimeters, 2 miles for that matter. And we'll draw an altitude from one of the vertices, and that is also a median line, and it not only bisects the angle, it also is a perpendicular bisector to the opposite side. So bisecting those angles means those are now two 30-degree angles, and bisecting the opposite side means that either one of those triangles has a base of 1. Okay. So that triangle on top or the bottom is now a 30, 60, 90 triangle. The bisected side is divided into 2 equal segments, and the bisected angle has now 2 30-degree angles. So how is this right triangle that was formed? Let's examine this closely. And we have the hypotenuse of that right triangle is 2, and the small side is 1, and we have a 30-degree and a 60-degree angle. So the only thing left to do is to solve for the unknown side, z, and that's this side right here. So how do we do that? Well, let's apply the Pythagorean theorem to find out the length of the unknown side. Recall the Pythagorean theorem says the square of the sum of the legs of the right triangle is equal to the square of the hypotenuse. And in this case, that means the hypotenuse is 2 squared is equal to z squared plus 1 squared. So 4 is equal to z squared plus 1 squared. And we subtract 1 from both sides. And you get 3 is equal to z squared, which, if you take the square root of both sides, means that the length z is equal to the square root of 3. And the question is, can we generalize this to all 30, 60, 90 right triangles? In other words, is it true for a triangle that is twice as big? Well, let's multiply all the sides by 2, and we would see that the small side is now 2, hypotenuse is now 4, and the side here is now 2 times square root of 3. How about a triangle that's half the original size? Okay, multiply all the sides by 0.5, and we would have the small side is equal to 0.1, the hypotenuse is equal to 1, and the base is now equal to 1/2 times the square root of 3. What about a triangle that is s times bigger? S just being a scaling factor, so it could be any number. Well, we would multiply the small side by 1, the hypotenuse by 2, and the base by the square root of 3. So the general result is, in a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is square root of 3 times as long as the shorter leg. An example with numbers would be this side is 10, this side is 20, and this side would be 10 times the square root of 3. Since the square root of 3 is approximately 1.7, this side would be 10 times 1.7, or about 17. So you would have 10, 20, and 17.